Good morning, dear listeners, and welcome to our today's class. Today, we are still continuing to discuss on the concept of bias theorem. Do you remember that in our last class we discussed the bias theorem still, but we limited our class to the derivation of a bias theorem when there are only two events, A and B, found in the sample space, with another event that is superimposed on it. So today, as a continuation of that class, we want to look at the derivation of bias theorem for n events that are found in the sample space. But first of all, it is important that we recall for ourselves one or two things that we did see in that our previous class. And what is that? By beginning with what we have in the class today, we said we are looking at a bias theorem or bias rule or bias law. So we have bias theory, bias theory, or rule or law. Of course, bias theorem is used in probability and statistics to determine the probability of conditional events. If you put it in another way, it is used to determine the probability of events, given the prior knowledge of the conditions of other events that might be related to this very particular event. That is what we do in the bias theory. But we have just spoken English, and we needed to see how this thing apply or how this thing work more in practical life than in mere definition. So we are going to carry you along by driving in very most explicit word form the formula of a bias theory for n events. And when, of course, we talk about n events, this our n could be what? 3, it could be what? 4, it could be anything. Our interest is that it has gone beyond the 2. Because when it was 2, we decided to use event A and B to showcase it in our last class. But today we are going to go beyond the 2 events to talk about 3, 4, 5 down events. So in this case, we are going to use what we call a Venn diagram to represent what we mean. So let me have a Venn diagram. So which means the second condition now is now driving bias formula for n events. Bias rule or formula. Bias formula for n events. N events in the sample space. Please permit me to write S like this as a sample space. Driving bias formula now for n events in the sample space. So let me use a Venn diagram to represent the sample space. I have a Venn diagram. This is my Venn diagram. Okay. This is my Venn diagram. I represent it with what? S. Talking about the sample what? Space. Okay. So I am going to partition this my sample space into n because I'm talking about n events. So let me do the partition in this way. I have this, and possibly I have this. Okay. Then let me say I have what? A1. Let me say I have what? A2. Then let me equally do a partition in this way. Let me equally do a partition in this way. So that I can have A1 here. A2 have something like what? Bump, 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 this way up to what? My AN. So to use this thing to show that there are n events here. This is my A1 event, this is my A2 event, down up to my AN events. Okay? So in that case now, let us assume that there is also another event that is superimposed on this sample space. And let that event be represented with a letter what? D. So I now say that I have a point here, and then there is a letter what? D. This D is another event that is superimposed on this sample space. And another thing we are going to bear in mind is that these events, A1, A2 down to AN, have two characteristics that they must have to satisfy. Number one is that they are mutually exclusive. That is, the intersection of any two different events must be empty sets, number one. And then the union of all the events from A1 down to AN will give us back our sample space. So mutually exclusive because intersection of two different events there is what? Empty sets, is empty. And then mutually exhaustive because the addition or the union of all the events there from A1 to AN will give us back our sample space. So in that case, this D, which is another event, is just superimposed on these events A1 down to AN. And we are saying that this event D superimposed here can actually occur when A1 is occurring. That is occurring alongside what? A1. Or it can occur alongside what? A2. Or it can occur alongside what? Down to AN. So the constraint there is, how do we drive Bayes' formula or rule or theorem for a situation like what this? We are going to make that derivation now using what we call the conditional probability. And then we are going to talk about the conditional probability of A1 event occurring, given that this event D that is superimposed on this sample space earlier had what occurred. So in that case, what I have here becomes, I have that probability, my P of what? A what? 1. Hmm? Given that my what? My D already had occurred, should be given as, remember that this is a conditional probability. And conditional probability is defined as the ratio of the joint probabilities of the events that is involved to the probability of the event that happened there earlier. And when we talk about joint probability in set, we are talking about the intersection of the events involved. What event are we looking at here? A1 and what? And D. So for me to express this now, it is going to be what? Probability P of what? A what? 1 intersection what? D. This is what we call the joint probability of A1 and D. All over. Probability of the one that had occurred earlier. P of what? Of D. I'll close it. Are we there? So I can easily say, okay, fine. I can easily do like this. All over 1 to cross multiply. And by cross multiplication, now what am I going to do? When this one multiplied by this, it gives me that. This one will multiply by this. And in that case, this thing implies 1 time this will give me what? P of what? A what? 1 intersection what? D. Close the bracket. This equals. This time this will give me what? P of what? D multiplied by, I have what we call P of P of what? A1 giving what? D. Close it. Of course, I can talk about the reverse probability here. The reverse probability here, I mean, is in the first one, what we looked at here is the probability of A1 occurring, given that D earlier had occurred. Then let us now talk about the probability of this D occurring, given that this my A1 earlier had occurred. And in that case, what I'm going to have becomes, I have P of what? Of D, giving my what? A what? 1. This equals The same thing is a conditional probability and must be presented as the ratio of their joint what probabilities all over the probability of the one that earlier had occurred, which in this context had become A1. So what I have here becomes what? P of what? D intersection what? A what? 1, then all over P of what? A1. That's what we now have here, P of A1. And like I did before, I can easily say all over what? 1 and cross multiply. This will go to this will go to this. And when this goes to this, it is implies that I will have this thing multiplied by this will give me P of what? D intersection what? A1 is given as this will give multiplied by this will give me P of A1 multiplied by, look at A1 here, multiplied by what? P of what? D giving what? A what? 1. Okay? See what I did? This one multiplied by this gave me this. This multiplied by this gave me this. This one multiplied by this gave me this. This one multiplied by this gave me this. This is what I have. Okay. Then, without wasting much of our time, we progress. Now, I want us to look closely at what we have here. What we have here is what? A1 intersection D, and then D intersection A1. A1 intersection D. Here is A1 intersection what? D. Intersection D. What we have here is what? Is D intersection what? A1. Remember clearly that when you talk about A1 intersection D, you are talking about those elements that are found in A1, which are equally found in what? In D. And when you talk about what? D intersection A1, you are saying those elements that are found in what? In D, which are equally found in what? In A. They are the same thing. Whatever elements that are common in A1 and D are common in what? D and A1, because this is just like you saying this one is written first when the other one comes what? Last. So if we agree that this quantity and this quantity are the same thing, it implies that their probabilities are equally going to be the same thing. And if their probability are the same thing, of course, this probability of A1 intersection D is going to be the same thing with probability of D intersection A1. And if this and this becomes the same thing, it implies that this quantity and this quantity are going to be the same thing. And if we agree, we write like this, which of course is true. We now say if. We say if P of what? A1 intersection what? D equals P of what? D intersection A what? 1. It implies that this quantity and this quantity are going to be what? The same thing. So I will now write. It implies that P of what? D multiplied by P of A1 giving what? D. It equals P of what? A what? 1 multiplied by P of what? D giving what? A1. Close of the brackets. Okay? Now our interest here is to make this our A1 giving D subject to formula, which of course we are going to call the Bayes law or formula in this our derivation. Okay? Now, that is the probability of A1, event A1 occurring, given that that event that is superimposed on it earlier had occurred. And for me to make it solid to formula, I'm going to divide both sides with probability of D, which is probability of that event that is superimposed on it. So I will now say all over P of what? D, all over P of what? D, close it. So that this P of D will cancel P of D. And what I'm going to have that this implies that P of A1 given D, it implies that P of A1 given D is equals P of A1 multiplied by, I have what? P of A1 multiplied by P of D giving A1 all over. Here is my P of D. I have P of what? Of D. There is something I want us to pay attention to. What I want us to pay attention to is this. You see that when we picked A1 alongside what? The event superimposed on it D, which we began from here. After touching and driving and the rest of them, we realize that this A1 given D can be expressed like this. If this A1 given D can be expressed by D, it implies that A2 given D, once you come to here, any place you find A1, remove it and replace what? A2. So if I want to get for that of A2, I'll come here and I'll see that my A2 is now going to be P of what? A what? 2 given D is now equals to given D equals. Here is my P of A1 and I'm talking about A2. So it is now going to be P of what? A what? 2 multiplied by. Here is P. Here is my what? D given. Here is A1 and I'm talking about A2. So it becomes what? A what? 2 close on the bracket all over what? P of what? Of D. If you agree with me that this can be expressed like this, it implies that I'm even interested in P of A3, which is this A2. Okay, I did not even include A3 here, but if you talk about A3 here now, it is equally going to be, for that of A3 now, it is now going to be, you have what? P of what? A what? 3 giving what? D is equals. Anywhere you see A2 here, you remove it and put A3, or anywhere you see A1, you remove it and put what? A3, and it becomes what? P of what? A what? 3 multiplied by P of what? D giving A what? 3 all over P of D. And if you agree with me that this is this, and agree with me that this is this, and agree with me that this is this, it means that up to my, sorry, dot, dot, dot. That language I use, I'm sorry, is a language that is within my dialect, please. Okay? So this is dot, dot, dot. Okay? So now, this is what? My AN. Okay? So, which means it moves down to what? To my AN. It means that my AN is good. P of what? A what? N. Giving what? D is now going to be. Anywhere you see A3, you put AN, and it becomes what? P of what? A what? N. Multiplied by P of what? D, giving A what? N, all over P of what? Of D. These are what we call the Bayes formula, or what we call the Bayes law of getting the conditional probability of event A1 occurring, given that another event that is superimposed on it earlier had what occurred. And that event superimposed it involves other sets that might be related to this. So that is even more reason why it is different from what is called conditional probability. In the conditional probability, you are interested in only two events. The probability of A occurring given that this has occurred. And it is just expressed straightforward as the probability of that two event, intersection of that event, or the probability of the one that had occurred earlier. But if you watch here now, you find out that even though you are talking about probability of A1, A3 occurring, given that D, but if you come to this formula, you still find that there is a formula. You have your A3 here, you have your what, your D here, you have your D here, and the rest of them. But there is something we are going to do. Because when we want to talk about this our D is not going to be seen as just like it is standing all alone. It is superimposed on all these events. And on trying to get the probability of what D now, you'll be able to link all these events from A1 to what to N. So in the Bayes theorem now, it goes beyond ordinary conditional probability when you are strictly confronted with what? Two events. Here, you are going to go beyond what? Two events to all the events defined on the sample space, which might be affecting that particular A1 that is occurring. Okay, that's what we do in conditional probability. Now, there is also something I want to mention here. If you watch, we are talking about how we can drive a conditional probability for events A1 to what? To N, with this D superimposed on it. We have arrived at this, and we are calling this thing that they are Bayes law or formula. But if you watch for this first one now, we only have A1 here and D. Here we only have A2 and D. Here we have A3 and D. Here we have AN and what? And D. By implication, none of them involved all the A1 down to what? To AN. So how are we going to factor this in here in this equation now, for us now to see that our proof for Bayes' formula is complete, we are going to do something very serious. And that which we are going to do very serious is this. Permit me to quickly come and clean here. Let me clean this place so that we can continue this our proof there. Okay? Permit me to clean here. 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 There's something I want to show us. The denominator here say P of D. The denominator here say P of D. The denominator P of D. P of D. This P of D, P of D is what we call the total probability in Bayes' theorem or in Bayes' word formula. So we are to determine the probability of this our D, P of D. So for us to determine the probability of P of D, one thing is going to come to our mind. What is going to come to our mind is this. That for us to give the probability of D, we bear in mind that this D can occur with A1. This D can occur with A2. This D can occur with A3. It can occur with A4 down to what, to AN. And for an event to occur with another event, we are talking about intersection. So for us to get the probability of this D, it is going to be probability of what D is equals probability of D intersection what A1, or probability of what D intersection A2, or probability of D intersection down to what, to AN. So we now come here and say P of D, or first of all we say D first. Our D first is given as D intersection what, A1, or D intersection what, A what, 2, or so, or dot dot dot, sorry, D intersection what, AN. Okay? Dot 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 dot, or D intersection what, AN. You have it this way. When we transform this into probability, what are we going to have? We are going to have that our D now, our P of what? Of D is now given as P of D intersection what? A1. Okay? This thing means plus in probability, or means plus. So we say plus P of D intersection what? A what? A2. Or means plus. We have what? This dot 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 plus, here is P of what? D intersection what? AN. We close it. So we move. Another thing that is going to assist us very, very well here is this. Watch. So we now say P of D now, P of what? D now equals. Remember that I already expressed here, watch here, I already have here that P of D intersection A1 is expressed like this. See it. That P of D intersection A1, and here is P of D intersection, is expressed like this. So in place of the whole of this, I am going to use this. Okay? So if I use this now, what I'm having here is what? P of A1, which is this, multiplied by, here is what? P, here is what? D, giving A1. Close it. That's what it is. I will say plus, because of this plus. Here it is D intersection A2, and here was D intersection A1, expressed like this, which is what I have here. So if I come to D intersection A2, what I'm going to do is, anywhere I see A1 here, I will change it and replace with what? A2. So in that case, it is going to be what? Plus. I will come here. P of what? A what? 2 multiplied by P of what? D intersection. Sorry, giving what? A what? A2. Close it, plus. Now I'll do dot 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 plus. I come over here. This is the intersection AN. So anywhere I see A2, I'll put what? AN there. So this thing becomes what? P of what? A what? N. Then multiply by P of what? D, giving what? A what? N. Close it. I want us to look here clearly. You see that my A1 is changing. Here is A1, here is what? A2, dot dot up to what? To AN. The same thing applies this. The only thing that is constant is this, and this. Every other one is running. So, but because they are running now, of course, we do not know the number of n, whether the number of n is going to be 3, whether it's going to be 4, whether it's going to be anything. So we can bring in the idea of what summation here. Bringing the idea of summation here is like, we are summing all this quantity up to n. So this thing becomes that d is equals. We have summation that our I is running from 1 to what? To n. Here we come. We write what? P of. Here is going to be what? AI. Close it. Multiply by this multiplication. Here is P into. Here is my what? My D. This is D. Giving what? Giving AI. You see, this whole thing we are summed up to n can be represented with this symbol. With this. It can be represented quickly with this. And when it is represented with this, it appears that all of this, which is probability of D, is given as, which means this is P of D. That P of what? D is given like this. Probability of D is given like this. And if probability of D is given like this, it means that we can quickly come here. In place of what? D here, we put in here. In place of D here, we put in here. In place of D here, we put in here. In place of D here, we put in here. So let us now, first of all, see the much we have done before we clean. We arrived at this. We recall that we needed the formula for what? For D. And look at the formula for D. And look at the name for D and the rest of it. So look at P of D, P of D, P of D, P of D. Found in this. We are trying to obtain this D because looking at what we have thus far now, none of them involved all the events from A1 to what? To N. They were strictly involving only events A1 or A2 or A3 down to what? To AN, alongside with what? D. And for us to talk about this bias theorem now, we are talking about event D superimposed on all these events. So the formula must have to connect all these events found in what? In the sample space. And we record to ourselves that for us to get the probability of this D, we return back here. We know quite well that for this D to occur, it can't occur alone here. That's the implication here. It cannot occur alone. It can occur with something. You understand? It's just like you come to a group of people, and then you are talking about selecting like, let me see, you have about 5 persons what in a class. And these 5 persons in the class now, they all have their individual probability of going to be selected into what? Into a group or a sample. But then there is anybody you selected now, the person is likely going to have what we call malaria. So meaning that malaria cannot occur all alone. You cannot select malaria. But on the course of selecting what students now, the malaria it occurs without selection. That's what we are trying to say there. So they can't occur all alone. It occurs with all these events here. Malaria can't occur all alone. It occurs with the students now being selected into that what sample, assuming that a student is a sufferer of that particular disease. So that's what we mean by this. We now said, okay, fine, that when you come here now, they cannot occur alone. It occurs with what? A1. And for something to occur with something now, you are talking about intersection in the language of what? Of set and set theory. So that's why you hear here. Either D occurs with what? A1, or D occurs with A2, or D occurs down with what? AN. Then turning this into probability, P of A given as P of D intersection A1, changing this plus to this all to plus P of D intersection A2 down to P of D intersection what? AN. And then bearing in mind that earlier on, this D intersection A1 already had been expressed like this. That this is D intersection what? A1 expressed this way. Okay, because it has been expressed this way, we quickly come back and say, okay, it means that we can express this our D intersection A1 to be this way. We express it this way, we say plus, which is this plus we arrive at here. We say if D intersection A1 can be expressed like this, it means that D intersection A2 can be expressed by changing all the position of A1 and A1 and replacing with what? A to A2. We quickly did it. Then down to what? To AN, which can be represented like this. We now said, okay, fine. Here we have A1, A2 down to AN, A1, A2 down to AN. We can actually write this using the sum that runs from 1 to what? N of AI, P of D, giving AI. If it becomes 1, it will arrive at this. It becomes 2, it arrive at this. Down to n, it arrive at this particular 1. Okay, that's exactly what we are doing here. So in that case, you are going to permit me to clean here. So I will call this our formula stop here now and use this thing under it. Thank you very much. So when I come to the first one now, I will now say that my first one now, my P, and then to even make this thing simpler here now, do you know, if you watch here now, this is 1, this is 2, this is 3, this is this. We don't know the particular one that they will ask us or they will ask us to pay attention to. So, and then if you watch here, this is still my A1, this is my A1, this is my A2, this is my A2. So I can easily come here now and use this formula here now. Instead of writing all this, repeating all this, I'll come here. This is my P of, here it becomes my what? My AI, giving what? D, giving D. Close it. D is equals. Here is my P of my A what? I, multiplied by. Here is my what? P of, I have what? I have my what? This is my D giving AI. Close it. Then I'll say all over. I'll carry this formula, which is summation. I is running from 1 to n of what? Of P of what? A what? I multiplied by P of what? D giving AI. This is Bayes' theorem or Bayes' formula. Proven. This is Bayes' formula. So if they are talking about maybe plant 2, plant B, or plant this, or plant that, you just come here. If they are talking about the second plant, it becomes A2. Talking about whatever, it becomes that particular one and this. So the probability of AI giving what D can be expressed as this. And with this, we don't have a problem again. So let us now try and solve another problem under this so that you see how it works. So permit me to clean this, okay? Okay, let me read. That question says, and I read, they say 3 companies, A, B, and C. 3 companies, A, B, and C. That company is 3. A, B, and C. Supply 25%, 35%, and 40% of the notebooks to a school. So A supplies what? 25%. B supplies 35%. C supplies 40%. Like I said earlier, if you watch here, 25 plus 35 plus 40 will definitely give you 100%. So any other thing we are going to talk about as an event here is going to be superimposed on this. By implication, probability of A is 25%, probability of B is 35%, and probability of C is this. Which of course you will bear witness with me that this is P of what? A equals 25%. Which of course 25 is 0.25. Here P of what? B is given as 35%, which you know is 0.35. And then P of what? C is given as 40%, which of course is 0.4. This is clear. 0.4. So we read on. The now says, past experience shows that 5%, 4% and 2% of the notebooks produced by the three companies are defective. Okay, so 5% is coming from A, 5%. So defective here now, defective. Let me write it what? Let me use D to represent defective. Defective here now is 5%. Defective here is 4%. Defective here is 2%. Is 2%. What do we mean by this? What we mean by this is that probability of defective given plant A is given factory A is what? 5%. Which means I'll write this now. P of what? D given A equals 5% is 5 over 100, which I think is 0.05. So here is 0.05. Coming over here. This probability of what? D given B, which is B, P of D given what? B, is equals what? 0.04. That is 4 all over what? 100. And then we have last but not least, P of what? D given C is given as a 0.02, which is 2% divided by that 100. So the question goes ahead to ask me, he said, obtain, yes, the probability of supplying a defective what? Item to the school where they are supplying that of defective what? Item. And 2, if a notebook was found to be defective, what is the probability that the notebook was supplied by A? Very beautiful or wonderful question which we are going to tackle with you. First of all, probability of the supply of a defective item. Of course, probability of a defective item is just like in that proof now, we had after expressing something, we had all over. In fact, let me now as a way of solution. We are talking about P of D. And remember that what gave us this numerator the other time is what? P of what? D. Because we had something like this. We had that P of what? A what? 1 giving what? D is given as P of A1 multiplied by P of D giving A1 all over P of what? D. And when we talked about P of D, we are talking about, remember that this P of defective they're asking us, defective can occur from factory A, can occur with factory A. Defective can occur with factory what? B. Defective can occur with what? Factory what? C. And you remember that that was what helped us to prove the probability of what? Of D. So the same thing now, if you agree with me, when we now say where, so I will now say where P of D, P of what? Of D is given as summation of what? I running from 1 to n. P of what? Of AI multiplied by P of D giving AI. That was the formula that we got for the total probability, which is the probability of defective item. How do we go about this? In very simple. Here I is running from 1 to n. Our own is running from 1 to 3 because 3 things are involved here. So I will now say this equals. We are going to start from I being 1. And I being 1 here means that we are talking about what? A. So if they talk about P of AI, I'm talking about P of what? Of A. So what is my P of A? 0.25. So I'll come and say 0.25 times. Probability of defective giving A. Probability of defective giving A. 0.05. 0.05. This summation will now tell me, I will say plus. I am done with I being 1, so I is going to be 2, and when it becomes 2, I'm talking about what? B. So when they talk about P of what? AI, I'm talking about P of B. And what is P? My P of B? 0.35. So I'll have what? 0.35 times. P of D giving B. P of D giving B is 0.04. 0.04. I will say plus. I am now into when I is what? I is what is 3. And when I is 3, now I should be talking about what? C. And then my P of what? C is not is 0.4. So I have what? 0.4 multiplied by P of D given C is 0.02. This is the probability of supplying a defective notebook coming from either A, B, or what? Or C. Probability of defective. Occurring alongside either A, occurring alongside either B, occurring alongside either A. Here it occurs alongside what? A, occur alongside what? B, occur alongside what? A. Yeah, sorry, C. This is I question they ask me. I question. In II, they ask me, given that a notebook is supplied in what in the school, I should find the probability that it is supplied from factory what? A, given that it is defective. So I am interested in looking for probability of A. I am looking at what? This is my II. I'm looking at probability of what? Of A, given defective. And remember that here is just the same thing like this. Here it is my AI. Here we are not talking about strictly A because they have called it a name. So this is going to be, what's my numerator now? Because I'm not talking about A alone. So this thing is now going to be defined as this is equals. Here is my P of A. This is my P of A multiplied by. Here is my P of what? D, giving what? Giving A, close it, all over. The whole of this my P of D, which is this. So this is the whole of my P of what? Of D. This equals. What is my P of A? 0.25. So I have 0.25 times. What is my P of D giving A? 0.05. So I have what? 0.05 all over P of D, which is this, which has been evaluated to be this. So I will say all over. This is 0.25 multiplied by 0.05 plus. Here is what? 0.35 times 0.04, 0.04 plus. Here is 0.4, 0.4 times 0.02, 0.02. So once you have your calculator, you can evaluate this, you can evaluate this, and then that becomes what the answer. Okay? So you see that what is required of us in Bayes' theorem, and likewise in so many other aspects of mathematics, is first of all having an upper hand in the derivation of what of the formulas and understanding the techniques or the connections between the variables or events in that particular word formula. With that in mind, you can go a long way to answering all the questions. Seeing what you have done with this and the rest of them, it means that every other related questions now on this, using what you have on the board, you'll be able now to find your way out of it. Obviously, we are out to see that you have a change in your understanding of mathematics and statistics. And I want to assure you that with time, you begin to see lots of changes in you. With your orientation, starting from your orientation about the subject matters, mathematics and statistics, down to your solving problems on them. The moment you understand these basic subject and the rest of them, you will navigate your way out so many academic struggles and the rest of them. Thank you very much, and wait for our next class when we should equally be discussing something very wonderful for you. This is our second class on Bayes' theorem. If you have not watched the first one, we encourage you go and watch the first one, watch the second one, and all about Bayes' theorem. You do not have a problem again. Thank you very much for your audience.